Greetings, welcome to our grade 11 mathematics channel. For this channel, we're gonna be uploading each and every month. We'll upload the test. We do run online classes, but for this channel, we're just gonna upload only the monthly test. Okay, so let's just start. So let's start with the question one. Question one says we need to solve for x, and we are given that for 1.1, let me write the 1.1.1, we have the 16 of x that is equals to the 1. Okay, once you have something like that, we all know that 1 raised to anything is gonna be, anything that is raised to the power of 0, let's say 16, is gonna be 1. So meaning here is gonna be 16 of x, that is gonna be equals to 16 to the power of 1. So then from there, what do? We have the same base, so we're just gonna equate our x to be 0. 1.1.2, we need to solve for this, whereby we have the square root, which is the radical sign. Once you have this one, we all know the procedure. You isolate your square root. After isolating your square root, you square both sides, then you solve. So for this case, we are lucky because the square root is subject of the formula now. So it's a matter of just squaring, then proceed. So we square both sides, so that we have the 2x plus the 7. Then this side, it is going to be 16 minus the 8x plus the x squared. Okay, then from there, you're just going to take this whole thing there to that side. After you're done the squaring, you try to solve for x. So it's going to be the x squared minus the 8x, then we transpose the 2x to that side, then becomes the negative 2x, then the 7 becomes the negative 7, then we bring back our 16 that we have there, then this is equals to 0 now. Then we say you have your x squared minus, we add the like terms there, it will become 10x, negative 7 plus 16, that one will be positive 9, and that is equals to 0. So if you factorize here, factorize, remember we're trying to solve for our x values. So the factors of 9, that can give us the 10 there. So I'm looking for the factors of 9. The factors of 9 are as follows: 1 times the 9. The other one is 3 times the 3. Okay, it is possible for me to arrange that one to give me a sum that is going to be a 10 there. So it's going to be 1 and the 9, so that I have the negative and the negative there. Then from there, it's a matter of just taking one bracket equate to 0 and the other bracket to 0, so that you have your x that is going to be equals to 1, or your x that is going to be equals to 9. Because we have a square root there, we need to go back and verify, check the validity of our solution. So we're just going to take our x values and substitute back there. So let's substitute. So we have the root of 2 into 1 plus the 7. I'm trying to verify if it would give me 4 minus our x value there is 1. So you know this one is going to be 2 plus the 7, that is 9. The square root of 9, that is positive 3. While this side you get 4 minus the 3, that will give us a 3. So meaning that x value there, which is 1, is valid. So let's check the one of 9. So we're going to have 2 times 9 there, and instead of x we have the 9 there. So 2 times 9, that is 18, plus the 5, that is 25. The root of 25 is positive 5 there. Then 4 minus the 5, 4 minus the 9 there, it will give us the negative 5. Then we see those two are not equals to each other, so we'll go back to the x of 9 and say that one is not valid. Okay, say if I didn't do this, what will happen? You're gonna be marked incorrect, like you'll be penalized 1 mark. Okay, you need to verify, you need to perform the validation. need to validate your things. Okay, with that being said, let me create some space. Okay, let's go to our question 2. We need to simplify there for our 1.2. We need to simplify. So we all know that 1 over 3, right, is the same as 3 of that one. Okay, but if I choose to raise this one to -2 and choose to raise that one to -2, you will see that it will become 3 squared, and that is going to be 9. Okay, so what I'm trying to emphasize to you is that if you have something like this, okay, so if you choose to change the exponent, what will happen to the numerator and the denominator will interchange. You have 3 over 1 that is raised to the positive exponent there. Okay, so that is why at the end we have the 3 squared, and that is going to be equals to 9. We'll use the same understanding that we have there to do what? Okay, we'll use the same understanding to say the following. We have the 1, we're just going to bring it down there, take there to the numerator. So you'll see that it would become the square root of p squared, and it would be raised to the power of positive 3 now. Then this is going to be equals to, you see that the 3 and the 3 there, they will cancel, or you can just perform on the traditional way of saying, if I remove the square root there, it's going to be 2 over 3 that is raised to the power of 3, and you see at the end you find your p squared. Okay, let's go to 1.2.2. For this one, once you see this, you see that we have 4 to the power of 2023, 5 to the power of 2021, 5 to the power of, so you see like there's somehow there's a common factor there, like there's something that is common. Okay, for example, I will try to eliminate the denominator that I have there. So how do I eliminate that one? So if I can figure out the common factor there, and in that common factor I'm trying to make sure that it does have that thing that I have there. Okay, so we'll see this is going to be equals to, let me reduce my pen a little bit. This is equals to, then you have the 5. Instead of 2023, you would say it's going to be 2020 times the 5 to the root of 3. So you know that the square root will apply there and apply there. Based on this fact, a times the b there is the same as root of a times the root of b. Okay, then you say minus, I'm creating a root of 2020, and it is multiplied by the 5, and this is over the 5. This is gonna be 5 2020. Okay, then I need to bring back the 45 that I have there. It's negative root 45. Okay, so this whole thing is squared. Okay, then from there you say this is going to be equals to, you have a common factor there, If you just factor out that one, you'll have 5 of 2020. Then what will remain inside there is going to be 5 root 3. So that is going to be 5 of root 5 minus the root 5. This is going to be all over the root there, which is found on our numerator, which is going to be 2020. Okay, then you say minus the 45, the root 45, you know that one, 45 is the same as 9 times 5. So it's the root of the 2. So it will become 3 root 5. Ne? So this one will be, okay, 3 root 5. Okay, this whole thing is squared, remember. Then from there, what do? You say, okay, that one and that one will cancel. Then I remain with 5 root 5 minus the root 5. Then you remember that we have that one there. So it's going to be negative 3 root 5. Okay. This whole set, it is squared again. So then we say equals to. So let's just treat our root 5 as x. Let's just treat that one as x. So if you have something of 5, x minus 3 of x, what is going to be the answer of that one? So clearly it is going to be x. So you'll see that, oh, for this case, this whole thing that is inside the bracket there become the root of 5 squared, and the answer of that one would become the 5. Okay, so that is how we simplify that one. Okay, they are the questions that are most interesting, and they like to come up for exams. Let me put it there. Okay, if our y is given as that one, so if I have to simplify the y there, 100,000 is the same as 10 to the power of 4 to the power of 4. Okay, let me confirm with my calculator. So it's 10 times 10 times 10 times 10 times 10. So it would be 10,000. Oh, it's to the power of 5. Okay, so it's 10 to the power of 5. So it's like you are given that your y value is equals to that one, and we have the 6 there. So if you have to simplify that one, it will become 10 to the power of 5 over the negative 6, which is the number that is outside the square root today. Okay, this is what we have. We know our y is equals to that one. Let's just take this thing and put it aside. We'll use it down the line. Okay, then the question says, without using a calculator, determine the value of, we are given that we have the root of the cube root of 16, the cube root of that, the cube root of that. We need to determine this in terms of y. So if they are saying in terms of y, in whatever that you're trying to do, make sure that the y is involved. So that is why you will say here, I will remove the square root. So what is the 16? 16 can be obtained by saying is 2 to the power of 4. Then since we are removing the square root there, it's going to be 1 over 3. Then multiplied by, we have that one, which is going to be 5 to the power of 4. And we also going to remove the square root. Then we have the 10 there. So the 10 is the same as 5 times 2. And that one's going to be raised to the power of 1 over 2. Okay. So from here, you'll say, let me simplify. So I have 2, then 4 times 1 over 3, that is going to be 4 over 3, times the 5 of 4 over 3, times, you know that the exponent would multiply with the exponents of the numbers that we have there inside the bracket. So that you have 5 of half times the 2 of the half. Then you see that we have the same base there. So we can just add the exponent. So it's going to be, if you say 4 over 3 plus 1 over 2, the common factor there is 6. Then it's going to be 8 plus the 3. Then it becomes 11 over 6. So it's 11 over 6. Then same thing applies to the 5. you see that for the 5 there, the 5 and the 5, you have the same base. You just take there, you just add the exponent. So again, it's going to be 4 over 3 plus the half. And we know the answer for that one is 11 over 5. So you know that if you have the same base, you can just multiply the exponents, right? Meaning that this is going to be 10 to the power of 11 over 5. What do you mean, say? You can say 2, this is the same as 2 times the 5. So it's 11 over 5. So this thing will give you exactly that one. Then you can just multiply everything that is inside the bracket there. Then it would give you a 10. Okay. With that being said, remember the question said we need to give our answer in terms of y. So we need to introduce the y now. We need to introduce the y that is equivalent to that one. So if you pause a moment and think about this, you know that this is going to be the same as 10 to the power of 5 over 5 plus, it's 6 over 6. 6 over 6 plus the 5 over the 6. Okay, because you're just going to take the 6 there, then add the exponent. So this is going to be equivalent to 10 to the power of 1 multiplied by the 10 to the power of 5 over 6. And you know this thing here is equals to our y that we have there. Okay, with that being said, you'll be like, okay, then this expression is going to be 10 times the y. So it's going to be 10 of y. Okay, just pause a moment and try to think about this. Your brain will comprehend this. Okay, let's proceed to question 2. We have our 2.1 there. Simplify the following expression. So we need to simplify this. So 125 and 5, you see there we have a similarity there, like because we know that the 125 is the same as 5 to the power of 3, because it's going to be 5 times 5, that is 25 times 25, that is going to be 125. So I have the 5 to the power of 3, that is raised to the power of x, then I multiply. Then since I have the square root there, how do I remove the square root? It will be 5 of 4x minus the 2. Then to remove the square root, I multiply with the half, so that I have that one. Then same thing applies to the one that I have there. I have 5 to the power of 12 plus the 6. Then I multiply with the 1/3 of that one. Then I multiply by the 5 to the power of x. When do we multiply with the half? When do we multiply with the 1/3? So if your square root doesn't have any number outside there, you multiply by 1/2. If your square root does have a number there, you'll have to do what? You'll have to multiply by that number that is there. Okay. So that we have that one as 5 to the power of 3x multiply by the 5 into, if you multiply by the half, multiply by the half there, it will become 2x minus the 1 over the outside exponent will multiply inside. Don't forget that, student, because I know that we tend to forget that one during the test or something. So it's going to be 4x plus the 2, then times the 5 to the power of x. And that one is going to be equals to, so you have the same base, same base. So it's going to be 5 of 3x. Because we're multiplying there, so we're just going to add. So it's going to be 2x minus the 1. Okay. Then you can just do everything at the same time, but so that we are all together. So we're just going to keep it like this. Then we see that if I compare those two bases there, I just multiply. So it's going to be plus the x there. So at the end, I will have the 5. Then I add the exponents. 3x plus the 2x, that one will give me the 5x. So I have the 5x minus the 1. Oh, my battery is low. Okay. Then this is over the 5. Then I add, there I have the 5x plus the 2. Okay, let me increase the bright a little bit so that you guys can see. Okay, then from there you have the same base 5 and the 5. You just take one base, then what do you do to the exponent? To say 5x minus 1, put the negative there, then put the bracket. You have 5x plus the 2 of x. Then at the end, that is going to be 5 of 5x minus 1 minus 5x minus the 2. So that at the end, we have those two cancelling each other. Then we have 5 to the power of negative 3, and that one is going to be 1 over 5 to the power of 3, and that is going to be equals to the 1 over 125. Is there any question? Okay. That is what we have for 2.1. Let's go for 2.2. 2.2 says solve for x. We're doing this. Now we are going to 2.2. Solve for x, and we're given that we have that one. So if you note here, you can divide by 6 both sides, so that you have the x to the power of 3 over 2, and that is going to be equals to 48 divided by 6. 6 times 6 is 36, then plus 12, so it's going to be 8. Then I'm concerned about obtaining the value of x because I'm solving for x. So meaning I need to eliminate the exponent that I have there. How do I eliminate the exponent? I will eliminate the exponent by saying I will multiply with the inverse of this. I'll just multiply with the inverse of that one, so that I have the 2 over 3. Even both sides I have the 2 over 3, so that I have the x that is going to be equals to, because the 3 and the 3 will cancel, the 2 and the 2 will cancel. Then you know that the 8 is the same as 2 to the power of 3 of 2 over 3. Okay, then at the end you see that the 3 and the 3 will cancel, will remain with 2 to the power of 2, and that is going to be equals to 4. Okay, this is going to be 2.2.2. 2.2 solve for x for that expression that we have there. So we have the x to the power of a half minus the 3 to the power of 1 over 4 plus the 2, and that is equals to 0. Okay, for this one, you can totally see that I have those two exponents. You know that if you say 2 times 1 over 4, you'll get what? You'll get 1 over 2. So meaning here I have the square root of that one. So it's like I have the x to the power of 1 over 4, that is squared, okay, minus the 3 of x to the power of 1 over 4 plus the 2, that is equals to 0. Then you'll see, okay, I have something that is common throughout. So I would like to make my k value to be x to the power of 1 over 4, so that I have the k that represent that thing that is inside the square root there, inside the bracket. Then we write to the square minus the 3. We do have x to the power of 1 over 4, so that is going to be k again, plus the 2, and that is going to be equals to 0. Then what do we do from here? We just open the 2 bracket, open the 2 bracket, open the 2 bracket, then equals to 0. Then we have the k, we have the k, and we have the k. Then the factors of 2, the 2 can be given by 1 times 2 only, and I need to make sure that I also able to get the sum of negative 3 there. So I have negative and negative from both sides. So then from there you're just going to equate each bracket to 0, so that you find your k to be 1 or your k to be 2. Then you remember that my k value there was that one. So if I just go a little bit and substitute back a k of 1 over 4, I substitute my k there as 1 over 4 again, then I have the 2. Then how do I go about solving for x? Remember, we're solving for x, so we're solving for this, and we have the exponent, so we need to eliminate the exponent. So we're gonna multiply with the reciprocal, so that you find your x to be equals to the 1, or your x is going to be equals to the 16. That is how you solve for that one. Okay. Okay, this was the last question for this one. We do have this question. We'll cover it on the next video. This was the test that this was our January test with my student, because we do have classes every Friday, Saturday, and Sunday. We do have online classes. Thank you so much. Don't forget to like, subscribe, and comment. Even share with your siblings or your classmate. Thank you.